Flexible Hydraulic Elevator Trim System, FETS, by Lucas Wolf, myself. The FETS is a conceptual system used to change the shape of a horizontal stabilizer in the elevator of a plane. The system will change the camber, symmetry, and thickness of the stabilizer. This is for the sake of controlling drag, lift, or whatever necessary control movements are necessary to keep the plane stable and pleasant to be on. This idea is a concept and will not be tested at the professional level for the sake that I am a high school student. This is a concept in its current state of development that will not be viable for use. Past technology. The discovery of the airfoil happened as early as Da Vinci, but was officially discovered by Horatio Phillips in 1884. Though this concept of the prolonged flight is not proven until the Wright brothers made their historic flight December 17th, 1903, toward World War II. The airfoil was improved and planes evolved to the next level, but the real innovation was the Nazis. This is the invention of the jet, the fastest form of travel. The real takeaway is that planes go faster. This caused the invention of the trim flap. This flap was a small flap found in the ailerons, vertical stabilizer, or rudder, flaps, and elevator. All this was with smaller flaps that would be put on bigger flaps to trim the aircraft, among with other things that we are left with today. But don't be scared. We've come a long way in safety, and the only really big problem now is the extra drag left with it, and even still, companies are making their planes more efficient every single day. My idea. The idea. I am I am 15. I do not have $5 million grant and a wind tunnel at my disposal. That simply is the main problem with my research. I don't have enough resources to make this a completely viable model of something. This sadly is a concept with no funding. On the side of what may be wrong with my concept is all designs of my systems would change for every single plane. I predict that there will be different version for each plane. The same as there's different components on different planes in the first place. One of the biggest problems I see is the panels will not be flush enough to improve efficiency. You will see this in a later slide. In the future, I see that aircraft, there will be a whole system to plan and automate our system using meteorology, the study of the weather. I imagine that it'll become a standard device in most aircraft. I intend to revisit the idea in the future, maybe after college. This is one of the first steps to the final step of aircraft before we eventually take a rocket and go across the entire world. Elon Musk. This, if implemented, is yet a new feature of planes. This will cause a surge of jobs as more computer scientists, mechanical engineers, physicists, etc. will be in demand. This influx of jobs, though small originally, will be necessary for many commercial aircraft in the future. One of the potential consequences is that FETs could fail and people could die. This is for everything in aviation. The fuel economy in aircraft will improve, hopefully. Also, the necessity for better hydraulic equipment will improve, and so companies will make hydraulics to increase the size, and yet more jobs will be made. Good for the economy. The common current design. As one can see, the common element consists of an elevator or horizontal stabilizer. As you can see, the airfoil becomes displaced in this image, and that requires energy. This is otherwise known as air resistance. That's why moving a plane, making it go up, actually does have a toll on air resistance. Those people who believe that a stable, flat airfoil will have no air resistance besides that of the leading edge, you are wrong. I am sorry. So when you tilt it down a bit, it displaces air downward, pushes it down, pushes plane up. That makes there be displacement of air, which again requires energy. And if you were to use versus the entire wing, like the second image shows, and use the top image, displacing using just the elevator, you end up having those turbulent little bits there at the bottom. And it becomes harder to do it not as one whole, but versus actually changing the entire elevator system, we'd just be changing the flap at the very end inside that elevator system. This is my design. On the contrary, from the current model, my elevator has hydraulic pistons. For the sake of my model, all the lines inside the airfoil shape. Those are those lines between all the circles. The hydraulics will connect the main spar or subspar that will then connect the main spar. As you can see by the smaller 6-inch cylinders relative to the 8-inch cylinder in the center that connected through a spar, and then all connected through a hydraulic system, and then everything else connected through hydraulic systems to either a subspar or a main spar. Also, you can see the panels of the airfoil um, along with the common and current control surface as the elevator. This brings into that part of potential drag because all those little divots could create bits of turbulence and drag that could screw things up for the aircraft, and that'd be bad. So if the sheet or panel that would go over all that, or adhesive or whatever it ends up, rubber adhesive or polyurethane something, was to go over it and wasn't to create enough smoothness, if you will, it would create too much drag, and the idea would be a viable, overcomplicated, and a waste of money and time. On that note, I hope I get in, and I hope to see you in New York. I obviously am in New York, but New York City, obviously.